Hello friends, welcome to a new video. Today we'll be discussing Leetcode problem number 347. So we are given an array here and we need to return the top k frequent elements. So for that let us take a look at individual integers and their occurrences. 1 occurs 3 times, 2 occurs 2 times and 3 occurs only 1 time. So once we record their occurrences, we can store it in a data structure like hash map. And once that is done, we need to now sort those numbers from starting from highest frequency to lower, and then we can return the uh, top to high frequency numbers. So for this purpose, one of the data structure that can be used is maxheap. So in maxheap, what happens is the root node will contain the integer with highest value, then 2 will be the second and 3 will be the third. So in order, if we use a maxheap, then the time complexity for reading and sorting the heap itself will be log n, and for because we'll be storing these values, we'll be traversing this array for, completely for the first time. So the overall time complexity becomes n log n, right? However, the problem statement expects that we should provide a time complexity lower or better than this. So another option that we can use is minimum heap. So in min heap, what happens is the integer with lowest value will be stored in the root node, and then the second, and then the highest frequency or the integer having highest value will be stored in this node. So it looks like a binary tree. And here the advantage of using min heap over max heap will be we can continuously monitor the size of our heap. So we know that our k value is 2. We just need the integers, top two integers with highest occurrences. So if our tree, for example, first we'll add 1 in our heap, then we'll add 2, and then when we try to add 3, the size will become greater than 2. So what we need to do is we just need to pop this out. In order to pop this out, there is a method called poll method. So once we use poll method, it will get rid of the root node with lowest frequency and we'll be left with the top to highest frequency. So this is the basic concept why min heap is more suitable to find out the highest frequency, top to highest frequency. And the time complexity for sorting k elements in min heap will be n log k. Now in max heap it was n log n. So here we are just maintaining two elements at any given time. If the size exceeds 2, then we'll get rid of it. So that's why the overall time complexity reduces from n log n to n log k. Now let us take a look how exactly it works. This is just a pseudo code. You can get the entire code in the code link description below. So this is how hash map will store the values for individual integers and their occurrences. So in key value format, and once the hash map stores these values, that is, then we can create a new min heap. And as you can see here, while we are creating the heap, we are defining the comparator in such a way that the value with lowest frequency will be stored in the root node first, and then it will go on to store the highest frequency. So if you see here, okay, and so while we are constructing the one by one, we'll start adding these values to the min heap. So here when we add the entry, okay, from the hash map that we stored here, so whenever we are adding the entry, that is 1 comma 3, so it will add it and then continuously check if the size is exceeding the whatever k value we have. So in this case it is 2. So first it will add 1 comma 3, that is 1 in the given heap, then it will add 2, and then when it adds 3, the size will exceed 2, and then it will use a poll method to pop this out, and then we'll be left with 2 comma 1. So then we can again use the poll method and get the keys of the two values, and we can just iterate it. So I hope you have understood how we can use a min heap and provide the optimized solution to provide the top k frequent elements for a given array. Thanks for watching the video.